It arrived from nowhere. Not from Mars, not from the asteroid belt, not from anywhere in our solar system at all. It came from another star, a star we cannot name, orbiting somewhere in the Milky Way, light years from here, a star that may have died before our own sun was even born. For 10 billion years, give or take, this object drifted alone through the black. No sunlight, no gravity to hold it. Just ice, dust, and silence, tumbling through the space between the stars. And then, on the 1st of July, 2025, it crossed an invisible line. It entered our solar system, and a robotic telescope in the mountains of Chile, built not to find comets, but to watch for asteroids that might kill us, caught it in the act. Scientists gave it a name, 3I Atlas, the third confirmed interstellar visitor in recorded human history. What happened next was extraordinary, not because 3I Atlas turned out to be dangerous. It isn't. Not because it turned out to be artificial. The evidence says it almost certainly isn't. It was extraordinary because, for the first time, humanity had the tools, the telescopes, and the time to actually study a piece of another solar system up close, while, in the background, one of the world's most famous astrophysicists stood up and asked the question everyone was thinking, but few dared to say out loud, what if it's not a comet at all? This is the real story of 3I Atlas, where it came from, what we've confirmed, what remains a theory, and where it's going now as it slips silently back into the dark, never to return. The story begins not with a bang, but with a blinking dot on a computer screen. In Rio Hurtado, Chile, sits one of 4 robotic telescopes that make up a NASA-funded early warning network called ATLAS, the Asteroid Terrestrial Impact Last Alert System. Its job is simple and a little grim: scan the sky every night, over and over, looking for anything on a collision course with Earth. On July 1st, 2025, it found something. A faint, fast-moving point of light, provisionally labeled A11PL3Z. At first glance, unremarkable, just another rock to catalog and forget. But when astronomers ran the numbers on its path, something didn't add up. The object was moving far too fast, on a trajectory far too sharply curved, to be caught in orbit around our sun. In the language of orbital mechanics, its path was hyperbolic. An open curve, not a closed loop. Anything moving that way isn't from here. It's just passing through on a one-way trip that started somewhere else entirely and will end somewhere else entirely, with our solar system as nothing more than a brief detour. This is confirmed, hard orbital data, not speculation. The object's eccentricity, a number that describes how open an orbit is, was measured at over 6. For comparison, a perfect circle has an eccentricity of 0. Earth's orbit is close to 0. Anything above 1 is not bound to the sun at all. 3I Atlas blew past that number several times over. It was moving at roughly 137,000 miles per hour when it was found, and it was still falling toward the sun, which meant it would only get faster. Word spread quickly through the global astronomy community. Researchers dug back through archived images from other telescopes, the Atlas networks and sister stations, and the Zwicky Transient Facility at Palomar Observatory in California, and found pre-covery images of the object dating back to mid-June, even earlier. Slowly, a fuller picture of its path came into focus. Then came the name. By convention, interstellar objects get an I designation, and this was only the 3rd one ever confirmed. The first, discovered in 2017, was called Wananai Oumuamua, a Hawaiian word roughly meaning scout, or messenger from Ilfar. The second, found in 2019, was 2I Borisov, named for the amateur astronomer who spotted it. This one would be 3I Atlas, named for the survey that caught it. Here's where it immediately became more interesting than its predecessors. Oumuamua, the first interstellar object ever found, was strange precisely because it seemed to have no comet-like activity at all, no visible tail, no cloud of gas, just a bare tumbling shape that some scientists still can't fully explain to this day. Borisov, the second, behaved like an ordinary comet, plain and simple. 3I Atlas split the difference in a way nobody expected, but the confirmed data made one thing clear almost immediately. This was an active comet. Ground-based telescopes detected a coma, the fuzzy envelope of gas and dust that forms around a comet's icy core when sunlight begins to vaporize its surface. It had a nucleus, and it had material boiling off that nucleus, forming a glowing halo around it. NASA's Hubble Space Telescope turned its gaze on the object in July and August of 2025 and captured something remarkable: a teardrop-shaped cocoon of dust streaming off a solid, icy core, with the background stars smeared into streaks behind it. The visual signature of Hubble tracking an object moving fast enough to blur the entire universe around it. Hubble couldn't yet resolve the solid nucleus itself. It was too small, too distant, too faint. But it could set limits. Early estimates placed the nucleus's diameter somewhere between roughly 440 meters and 5.6 kilometers. A huge range, admittedly, but enough to know this was no speck of dust. This was a real, solid body, just impossible to measure precisely from so far away. And when the calculations for its origin were run, they revealed something almost poetic. 3I Atlas approached us from the general direction of the constellation, Sagittarius, the same direction as the crowded ancient core of our own galaxy. A visitor, quite possibly, from the deep and crowded heart of the Milky Way itself. There was one more confirmed detail that mattered enormously to scientists, even if it sounds small. The speed of 3I Atlas relative to the Sun, its so-called hyperbolic excess velocity, was measured at roughly 58 kilometers per second. That number matters because it tells astronomers something about how old this object likely is. Objects ejected more recently from nearby star systems tend to drift slower. An object moving this fast, on this steep a trajectory, suggested it had been flung out long ago from far away and had spent an immense stretch of time simply falling through the galaxy before gravity ever brought it near us. Compare the three known interstellar visitors side by side, and 3I Atlas immediately stands apart. Oumuamua was small, elongated, tumbling, and showed no confirmed outgassing at all, a genuine puzzle that scientists still debate today. Borisov looked and behaved almost exactly like a standard solar system comet, reassuring in its ordinariness. 3I Atlas was different from both, large enough to be measured with confidence, active enough to display a real coma and tail, yet strange enough in its chemistry to make it the most scientifically valuable interstellar object found so far. For astronomers, that combination, a genuine active comet, big enough and close enough to actually study in detail, was the real prize. Not a rumor, not a hidden signal. The prize was data, a direct physical sample of the chemistry of a planetary system that formed around a completely different star. By late summer 2025, one fact was undeniable and fully confirmed by observatories across the planet. Humanity was watching a genuine piece of another star system, pass through our own, only the third time in recorded history this had ever happened. And it was about to get a lot stranger before it got clear. Here is where the story splits in two, and where it's absolutely critical to separate what scientists confirmed from what one particular scientist speculated. As 3I Atlas raced toward the Sun through the autumn of 2025, astronomers noticed small, real irregularities in its motion. Comets don't always move in perfectly predictable ways. As they heat up, jets of vaporizing gas can act like tiny thrusters, nudging their path off a purely gravitational course. Scientists call these non-gravitational forces, and they're a completely normal, well-understood phenomenon in comet science. Researchers at the Center for Astrophysics at Harvard and Smithsonian, among others, confirmed that 3I Atlas's orbit was showing exactly this kind of subtle deviation. Small, still being measured, and, as one astronomer put it at the time, still carrying fairly large uncertainties because the comet's true nucleus remained impossible to directly resolve. This was real, published, confirmed data. Nothing sinister about it. Comets wobble. This one wobbled a little differently than expected, and scientists set out to measure exactly how. But it was around this same time that a much louder, much more provocative narrative began to take hold, not from NASA, not from ESA, but from one man, Dr. Avi Loeb, a theoretical physicist and former chair of Harvard's astronomy department. Loeb had made headlines before. Back in 2017, he was the most prominent scientist to suggest that Oumuamua, the very first interstellar object, might not be a natural rock at all, but possibly an artifact of alien engineering, perhaps even a fragment of a solar sail. That idea was controversial then, and remains unproven and largely rejected by the wider scientific community now. So when 3I Atlas showed up, many astronomers braced themselves. And sure enough, Loeb, alongside a small number of collaborators, began publishing papers and public statements raising the same question again, this time with a new set of anomalies as his evidence. It is critical to state plainly, none of what follows in this section is confirmed scientific consensus. This is one contested hypothesis, not verified fact. Loeb pointed to several things. He noted that the object would swing near Mars, Venus, and Jupiter on its way through the solar system, an alignment he calculated, by his own estimate, had only about a 0.005% chance of happening naturally. He highlighted that the comet's closest approach to the Sun on October 29, 2025, would occur while the object was hidden from Earth's view, positioned on the opposite side of the Sun. Timing he described as suspicious, even suggesting the public take vacations before October 29th. A comment that ignited a wave of internet speculation and conspiracy theories about a supposed cover-up, He also seized on a glow observed in a Hubble image from July 21st, 2025, on the sunward-facing side of the comet, suggesting, again, as a hypothesis, not a finding, that it could indicate an internal power source rather than ordinary reflected sunlight. At various points, Loeb and his co-authors floated ideas ranging from an unusually large size estimate to reports of nickel-related signatures in the coma to the object potentially being technological in origin. Even, in the most extreme framing of his papers, a hostile probe, though Loeb himself repeatedly stated the more likely explanation remained natural. The reaction from the broader scientific community was swift and largely unified. Richard Moisel, head of planetary defense at the European Space Agency, stated directly that there had been no signs pointing to a non-natural origin in any of the available observations, describing the object as a natural, likely space-weathered body with relatively weak cometary activity. Other astronomers, including researchers who had spent years examining Loeb's earlier claims about Oumuamua, were considerably blunter, publicly describing the alien technology hypothesis as lacking any real evidentiary basis, and cautioning that extraordinary claims of this kind require extraordinary, and so far entirely absent, proof. Even inside Loeb's own published work, the language was more careful than the headlines that followed it. In the paper that triggered the biggest wave of coverage, Loeb and his co-authors explicitly wrote that the most probable outcome remained a completely natural interstellar object, most likely a comet, and that they were, in their own words, awaiting the astronomical data that would confirm that likely origin. That's a crucial distinction lost in nearly every viral headline. The scientist raising the alien hypothesis was, at the same time, on the record saying the mundane explanation was still the most probable one. The controversy wasn't really a 50-50 scientific dispute. It was a handful of provocative questions, stress-tested loudly and publicly against a wall of accumulating ordinary verifiable data. That didn't stop the story from spreading. Segments aired on national television. Members of the United States Congress publicly referenced the possibility of a cover-up. Online communities dissected every NASA image release for hidden meaning and every delay, and publishing new data became, to some, evidence of concealment rather than the far more mundane reality of scientific peer review simply taking time. It became, for a few months, one of the most talked about objects in the solar system, not because of what scientists had proven, but because of what one voice suggested might be possible, and how eagerly the public leaned into that possibility. So where does that leave us at the end of part 2? With a genuinely fascinating natural object, showing small, real, measurable irregularities that scientists were actively working to explain, and running parallel to that, legitimate research, a viral, unproven, and largely unsupported theory that captured public imagination far more than it captured scientific credibility. The only way to settle it was to keep watching. And that's exactly what the world's most powerful observatories did next. If part 2 is about suspicion, part 3 is about evidence, the largest, most coordinated observation campaign ever aimed at an interstellar visitor. As 3I Atlas disappeared behind the sun in late 2025, it briefly became unobservable from Earth. But it didn't disappear from human eyes entirely. This is where the story becomes genuinely cinematic, because humanity, it turned out, already had eyes in exactly the right place. The European Space Agency's JUICE spacecraft, the Jupiter Icy Moons Explorer, launched years earlier on a mission to study Jupiter's moons, happened to be positioned somewhere in the solar system with a usable vantage point on the comet during this window. On November 6, 2025, just a week after the comet's closest approach to the sun, ESA engineers turned 5 of JUICE's scientific instruments toward 3I Atlas and captured over 120 images using its Janus camera, alongside spectral and ultraviolet data from 4 other instruments. In total, the spacecraft gathered more than 11 gigabits of confirmed scientific data on the comet, though because of the spacecraft's orientation at the time, that data had to be stored on board and couldn't be transmitted home until JUICE reached a cooler operating phase in January 2026. ESA's Mars orbiters, Mars Express, and the ExoMars Trace Gas Orbiter also turned their instruments toward the comet during this period, giving scientists yet another angle on the object as it swept past the inner solar system. When the data finally came down and the analysis began, the picture that emerged was consistently, overwhelmingly natural. The confirmed findings piled up. NASA's James Webb Space Telescope, using its NIR spec instrument, analyzed the comet's chemistry in detail. In a study published in the journal Nature in June 2026, led by NASA Goddard's Martin Cordner, researchers confirmed the comet showed a methane-to-water ratio roughly 11 times higher than any other comet ever measured in our solar system. An extreme, but entirely natural chemical signature explained by ordinary thermal outgassing as ice heated by sunlight. Alongside that, isotopic Analysis found trace carbon-13 signatures consistent with ice that formed in an extraordinarily cold environment, colder than 30 Kelvin, nearly 250 degrees below 0 Celsius. Combined with other measurements, this evidence pointed to an estimated age for the comet's material of somewhere between 10 and 12 billion years old, meaning the ice inside 3I Atlas likely predates the formation of our own sun and solar system by billions of years. This is, without exaggeration, some of the oldest confirmed material ever directly studied by human instruments. Other observatories added further confirmed pieces. Radio. Telescope arrays detected elevated methanol levels in the comet's coma. Separate observations detected a hydroxyl radical trail, a chemical byproduct of water breaking down under sunlight, further confirming active, ordinary cometary behavior. Elevated deuterium levels, a heavier form of hydrogen, offered yet another consistent clue pointing toward the comet's ancient and undisturbed origin. And then there was the search for the anomaly hunters had been waiting for. In 2026, the SETI Institute used the Allen Telescope Array at the Hat Creek Radio Observatory in Northern California to scan a wide range of radio frequencies for any sign of artificial technological signals coming from 3I Atlas. This was, by the team's own description, one of the most sensitive searches of its kind ever conducted. Sensitive enough, according to some reporting, to have detected a signal as weak as an ordinary smartphone transmitting from that distance. The result, confirmed and published, nothing. No signal. No technosignature. No evidence of artificial origin whatsoever. A finding fully consistent with everything else the world's telescopes had found. Meanwhile, an audacious idea was taking shape around Jupiter. Researchers, including, notably, Avi Loeb himself, working this time within mainstream orbital mechanics rather than speculation, proposed redirecting NASA's aging Juno spacecraft, already in orbit around Jupiter, to intercept 3I Atlas as it passed the giant planet in March 2026. The calculations showed that, with a carefully timed engine burn, Juno could potentially close to within tens of millions of kilometers of the interstellar object, turning a spacecraft built for one mission into an unplanned interstellar research platform. The comet made its calculated closest approach to Jupiter in mid-March 2026, continuing to be tracked by ground and space-based instruments as it began the long journey back out of our solar system. Ground-based radio observatories joined the effort, too. The Atacama Large Millimeter, Submillimeter Array, ALMA, contributed some of the most sensitive chemical measurements of the entire campaign, confirming record methanol levels in the comet's coma and helping cross-check the findings coming from space-based telescopes. Taken together, 5 radio telescopes spread across 3 continents took part in the broader search for any unusual signal, forming what researchers described as the most sensitive search of its kind ever attempted on an interstellar object. Sensitive enough, by some estimates, to catch a signal no stronger than an ordinary cell phone transmitting from that same enormous distance. Every instrument, on every continent, kept returning the same confirmed verdict: natural chemistry, natural behavior, no artificial signal of any kind. It's worth pausing here to appreciate the sheer scale of the effort. Within the space of about a year, Comet 3I Atlas was observed by Hubble, by the James Webb Space Telescope, by X-ray observatories XMM Newton and XRISM, by ESA's Mars Express and Trace Gas Orbiter, by the JUICE spacecraft en route to Jupiter's moons, by the Allen Telescope Array, by ALMA, and by ground-based observatories on nearly every continent on Earth. No interstellar object in history had ever been studied this thoroughly, this quickly, with this much of humanity's scientific infrastructure turned toward a single, fleeting target. That, on its own, regardless of which theory turns out to be right, is a historic scientific achievement. By the middle of 2026, the scientific consensus had solidified about as firmly as consensus in astronomy ever does. The 3I Irish Atlas was real, it was ancient, it was chemically extraordinary, and it was, overwhelmingly, a comet, a completely natural traveler that happened to be carrying secrets from another star system entirely. So, what is actually happening with 3I Atlas? Strip away the headlines, the vacation warnings, and the viral theories, and here is what stands as confirmed, verified fact, drawn directly from NASA, ESA, and the broader global scientific community. 3I Atlas is a genuine interstellar comet, the third, ever confirmed, discovered by the Atlas Survey on July the 1st, 2025. It formed around another star, was likely ejected from that system billions of years ago, and has been drifting silently through interstellar space ever since, quite possibly since before our own sun existed. It made its closest approach to the sun on October 29th, 2025, safely inside the orbit of Mars, and its closest approach to Earth was a comfortable 170 million miles away, never posing any danger to our planet at any point in its journey. It carries an unusual ancient chemistry, high methane, high deuterium, a rare isotopic fingerprint. All that offers scientists a genuinely rare direct sample of material from a planetary system that isn't our own. And after extensive, sensitive searching, no evidence of artificial origin, no radio transmissions, and no technological signature of any kind have been found. What remains theory, clearly, explicitly theory, championed by a small minority within the scientific community and led primarily by one prominent but controversial physicist, is the idea that some of the comet's behavior might indicate something engineered rather than natural. It is a hypothesis that has been raised, studied, and so far not supported by any of the confirmed data gathered by the world's most sophisticated instruments. Good science doesn't punish someone for asking the question, but it also doesn't let a question substitute for an answer. And right now, the answer, backed by observatory after observatory, instrument after instrument, is the same. This is a comet. But maybe that's not actually the less exciting ending. Think about what that really means. A piece of rock and ice formed around a star we will likely never identify, in a system that may no longer even exist, drifted alone through the void, through cold, through dark, through unimaginable spans of time. For perhaps 10 billion years, longer than our sun has existed, longer than Earth has existed. It carried its frozen secrets past dead stars and empty light years, asking nothing, going nowhere in particular, until, for one brief cosmic instant lasting barely a year, its path crossed ours, and we were ready. Telescopes in Chile caught the first glimpse. Hubble and Webb studied its chemistry. A spacecraft built to study Jupiter's moons turned its cameras toward it instead. Radio dishes listened for a voice that wasn't there. An aging probe orbiting Jupiter was nearly redirected to chase it down. For a few months in 2025 and 2026, an entire species turned its collective attention, its billion-dollar instruments, its brightest scientists, its endless curiosity, and its wildest imagination toward a single wandering fragment of another world. It didn't stop. It was never going to stop. Even now, 3I Atlas is speeding back out into the dark beyond Jupiter, fading from view, carrying its ancient ice back into the space between the stars, on a path that will never bring it near us again. We didn't change its course. We didn't board it, or decode it, or find anything hiding inside it. What we did was simpler, and in its own way, just as remarkable. For one fleeting moment, we truly looked carefully, rigorously, without flinching from the strange possibilities, but without surrendering to them either. We measured what could be measured. We questioned what needed questioning, and we let the evidence, not the excitement, have the final word. Consider, too, the odd and very human shape of this entire story. A defense telescope, built to protect us from impacts, found a visitor that was never any threat at all. A Jupiter mission, built to study icy moons, ended up photographing an object made of far older ice than any moon in this solar system. An aging spacecraft, already past the middle of its working life, was almost given one last, unplanned adventure chasing a stranger from another star. And a single controversial scientist, right or wrong, forced an entire planet to pay closer attention to a comet than it otherwise ever would have. Science doesn't always move forward in straight lines. Sometimes it moves forward because someone asks an uncomfortable question loudly enough that everyone else has to go check one more time, very carefully to be sure, and they checked. Observatory after observatory, instrument after instrument, continent after continent, the answer held steady. That, in the end, is the quieter, less sensational headline, but it may be the more important one. Our systems for testing extraordinary claims against real evidence worked exactly as they were supposed to. Nothing was hidden, nothing was covered up. The data was slow sometimes, and science is rarely as fast as the internet wants it to be. But it arrived, it was checked, and it was shared. Somewhere out there, other stars are ejecting other fragments of ice and rock into the galaxy right now, at this very moment. Some of them, someday, will cross paths with us too. And when they do, we'll be watching the same way we watched this one. Not because we expect to find aliens, but because every single time there's a real chance we might learn something we never could have imagined about the universe we actually live in. 3I Atlas came from another star. It found us awake, watching and asking the right questions. And then, just as it arrived, silently and without looking back, it left